Let's talk about functions with variation. First off, we have a few different types. We have direct variation, inverse variation, joint, and combined. So essentially what we have with these is we're looking for keywords. So for instance, words like varies directly or directly proportional. What this means is if you have something that varies directly, that means as one goes up, the other goes up. As one goes down, the other goes down. Okay, so if we say cost is directly proportional, so we're going to have equals K to length. Okay, so say we were going to build a fence and we want to know the length of the fence panel. Okay, so cost is directly proportional to length. Now you're probably asking, where does the K come in? Well, K is just some fixed non-zero real number. And it's also called the proportionality constant. So each of these you're going to have an equals K. All right. So say your pay varies directly with the number of hours you work. Okay. So think about that. So this is your pay. This is the number of hours you work. Your K here would be the amount of money you make per hour. So say you make $10 per hour. Okay. So $10 for every hour that you worked will give you your pay. So that's where that K comes in. Your K is not going to change. Whereas if your hours go up, your pay will go up. As your hours go down, your pay goes down. Okay. So that's direct variation. Inverse variation means Y varies inversely or is inversely proportional. Those are the keywords that you're looking for. And what that means is as one goes up, the other goes down. Okay. So maybe the amount of time that it takes you to paint a fence will go down as the number of people that are painting the fence goes up. So obviously the more people, the less time, the less people, the more time. So that's an inverse relationship. Okay. So if I said J is inversely proportional with P. Okay. So J is inversely proportional with P. So we're still going to have the K in the numerator because that's that fixed non-zero constant. And our P will be in the denominator. Okay. Joint variation means that there's more than one. So varies jointly or jointly proportional. So if we say R is jointly proportional with P and Q, okay, we would write it like that. We still have the K here. The K does not go away. We still have a K. Okay. All right. And then combined variation. That means that there's some that could be directly and some inversely. So the easiest way to remember this is anytime you hear the word inversely, it goes in the denominator. Everything else goes in the numerator. So if I say V is jointly proportional to R and N, and inversely with D. Okay, it would be like that. Okay, so only D went in the denominator because I said the word inversely. Okay, so let's look at a few examples of this. Okay, the time it takes to cut grass is inversely proportional. There we go, inversely proportional to the number of groundskeepers cutting the grass. Okay, so we need to figure out what we have. So the time it takes to cut grass. So we're looking at time and number of people. Okay. So the time it takes, so time and the number of people. Number of people. So we need to come up with a variable to represent each of these. And you can use whatever variable you want. I'm going to use T for time and P for people. Okay. So the time it takes, so time is inversely proportional, so equals K divided by, because it inversely proportional means to divide with the number of people. Okay, and it says if 15 groundskeepers can do the job in 5 days, how many days would it take for 10 groundskeepers? So here's kind of the way you need to think about this. When you see the word if, that's the first part. Okay, then, or how many, in this case, that's going to be the second part of the equation. So let's do the if part. So if 15 groundskeepers can do the job in 5 days. So what is T here? Well, T here for this first part, the time is 5 days. And the number of people here would be 15. So let's plug in what we have. So 5 is equal to K over 15. So we're going to solve for K first. So that first part, the if, you're going to solve for K. Solve for K. All right. So let's solve for K. K is equal to, since I'm dividing by 15 to get the 15 out, I need to multiply both sides by 15. When I do that, I end up with K equals 75. So now my number 2, the second part of the then statement, how many days would it take for 10 groundskeepers? So T is equal to P is equal to. Well, in this case, 10 groundskeepers refer to the number of people, so that's 10. So the T is what I'm solving for. So my new equation looks like this. T is equal to 75 over P. And then I was given that P was 10. So T is equal to 75 divided by T, or I'm sorry, divided by P, which is 10. So that's what, 7.5? And what are we referring to? Well, T is time, and this is in days. All right, now when you get to the end, you want to ask yourself, does this answer make sense in the context of your problem? Well, let's see, if it took 15 people 5 days to do the work, and we're going to have less people, which should take more days. 7.5 seems reasonable if we're going from 15 to 10 people and going from 5 days to 7.5 days. Now, if say we had calculated this out and we got like 2.3, well, that wouldn't make sense that more people would take, less people would take more time, okay? Or less people would take less time. Sorry, I said that wrong. Less people would take less time. Okay, so always verify that this answer makes sense. Okay, all right, let's look at this one. The cost of a fence that is 200 feet long and 5 feet high is $3,000. If cost varies jointly, there we go, varies jointly with length and height, then what is the cost of a fence that's 250 feet long and 6 feet high? So this is the first part, this is the number 1, and this is the number 2. Okay, so that's the second piece. So we're going to do the first piece. We're going to solve for K. That's always what you're going to do. You're going to solve for K. All right. So let's see. We have cost of the fence, and then we have a length and a height. Okay. So let's find variables to represent cost, length, and height. Cost, I'll use C. Length, I'm going to use a cursive L, and height would be H. The only reason I'm using a cursive L is if I just use L for length, it looks like a 1. So you got to be careful with that. Okay. All right. So what was the cost of the fence originally? Well, it was $3,000. The length was 200 feet. 200 feet. And the height was 5 feet. Now it says cost varies jointly with length and height. So cost varies jointly with length and height. Don't forget that K, because that's what you're going to solve for in the first piece. So this is problem number 1. So the cost is $3,000 is equal to K times my length, which is 200 feet, times my height, which is 5 feet. Okay, multiplying this out, 200 feet times 5 feet is 1,000 feet squared, or square feet, is equal to $3,000. Solving for K, divide both sides by 1,000 feet squared. So we have $3,000 divided by 1,000 square feet. So K is what? $3 per square foot. Okay, so that's kind of how we would solve for K. So now our new formula is going to be C is equal to, because we've already solved for K, $3 per square foot times my length and my height. All right, so here's the second part. What is the cost of a fence that's, let's see, my length here is 250 feet and the height is 6 feet. Okay, so this is part 2. So number 2, the cost is equal to $3 per square foot times the length, which is 250 feet, times the height, which is 6 feet. This foot is square foot, cancels out with that one. So what I have is $3 times 250 times 6, which gives me $4,500, and that's the cost. So again, in this section, you always want to set up the equation. The way you do that is you figure out what variables you're going to use to represent each piece, and then you're going to have your K. Your K is always going to be in these problems. If you do not have a K, the problems are wrong, okay? All right, let's look at this one. If cost is directly proportional to size, so let's see, cost and size, and a 3,620 square foot house costs $514,750. Then, okay, so that's part 2. This is part 1. So let's see. It's a cost was $514,750, and the size was 3,625 square feet. Okay, and it says cost is directly, so equals K, directly proportional to size. All right, so first part, let's solve for K. So we have $514,750. $514,750 is equal to K times the size of the house, or 3,625 square feet. Okay. To solve for K, since we're multiplying by K here, we're going to divide. So I have 514,750 divided by 3,625 square feet. So K is going to be equal to what, $142 per square foot? Okay. So let's look at the second piece. So C is equal to 142 square feet times S. And they said, what is the cost of a house that's 2,315 square feet? So 142 per square foot times 2,315 square feet. Oh, sorry, that is the size, but we're dealing with the cost. So when I multiply this out, I end up with $328,730 because feet squared and feet squared cancels, and I'm left with $328,730. And that should make sense. Bigger house, higher the cost. Smaller house, the less price. Okay. All right. Problem number 4 is a little bit different because notice this doesn't give us a word problem. It just gives us some values. It's W varies directly. So varies directly with M and inversely with the square of T. So let's see what we have. So W varies directly. So don't forget your equals K with M, and inversely. So anything after the word inversely gets divided by the square of T. So the question is, which one of these is this talking about? The square of T. Well, here's the thing. Unless you see the word root, it's not that one. That one is the root. So the square of T would be T squared. Okay. I always like to bring that up because a lot of times students will give the square root of T, but square just means the power. Okay. All right. Now part 1 says if, so this is part 1. So part 1 says if W is 480, M is 5, T is 4, then, so that's part 2. So let's do part 1 first. So 480 is equal to K times M over T squared. So we have 480 is equal to K times 5 over 4 squared. 4 squared is 16. Solving for K, I want to multiply both sides by 16, and then I'll be dividing by 5. Okay, so if I multiply both sides by 16, I end up with 7680 is equal to K times 5. Solving for K, I end up with 1,536. So for part 2, my new formula is W is equal to 1,536 M over T squared. Okay, you always have to solve for that K first. Okay, what is M? What is W when M is 3? So W is equal to 1536 times 3 divided by 6 squared. So 1536 times 3 divided by 36. So multiply by 3, then divide by 36. Your W is equal to 128. So that's the answer. W is equal to 128. Okay. All right. I want you to try this problem. So pause the video and see what you get. This one's a little bit tricky, only because there's a lot of words in it. So you got to get rid of the minutia and figure out what it's asking you to do. So pause the video. Okay, assuming you have paused the video. The intensity of illumination I from a light source varies inversely. As the square of the distance. So square of the distance and the intensity of illumination. So they tell us I is our intensity, and D is our distance. Okay, so let's see, I is equal to K over the square of the distance, so D squared. Okay, so the intensity of illumination varies inversely with the square of the distance. All right, so let's see, 300 candle power and a distance of 2 meters. If you're not sure which is which, always try to find the one that you know. Well, we know distance, 2 meters. So intensity would be 300 candle power. I'll put CP. So part 1, the intensity was 300 candle power is equal to K over D squared. So 2 meters squared. So K over 4 square meters is equal to 300 candle power. Solving for K, 4 times 300 is 1,200 candle power meters squared. Okay, so my second part would be I is equal to that 1,200 candle power meters squared over D squared. All right, what is the intensity of the flash at a distance of 10 meters? So 10 meters here, so 1,200 divided by 10 meters squared. So remember, this is candle power meters, meters squared, and meter squared will cancel. Candle power meters squared over 10 squared is 100 meters squared. These cancel, leaving me with 12 candle power. Okay, let's make sure our answer makes sense. When it was close, it was brighter. As it's further away, it's not as bright. So that makes sense. Okay, so that's how you do functions with variation. I encourage you to use variation for all of these, even if, like this one, you could have solved it a different way, but I would encourage you to use variation, because when you get to problems like this, or some of the more challenging problems, you won't necessarily know how to solve it. But your key to remember is the first part of the problem you're solving for K. The second part, you're putting the K in and then solving the second piece, the then part. All right, let me know if you have any questions.